Bismillahirrahmanirrahim. Assalamu alaikum students. So this lab is about sequencers and we are going to use them in Logix Pro. As you know that the Allen Bradley PLCs are not rightly available to us because we are going online. So the objective of our lab is to understand the operation of sequencers and simulate the given tasks in RS Logix Pro. So what are sequencers? The sequencer instruction is used when a repeating sequence of outputs is required. The sequencer instruction allows the PLC to implement this common control strategy. So in easy words, what a sequencer is, that when you need a sequence control of outputs, for example, you have 4 bulbs and you have numbered them 1, 2, 3 and 4. So when in the first turn, in the first true input, you want that the first bulb goes on and the rest are off, while in the second toggle, when you turn the switch off and turn it on again, you want that the first bulb goes off and the rest 3 bulbs go on. So such type of a sequence, such type of a memory is required, and this is implemented with the help of a sequencer when you require different outputs to be controlled by a single component. So the desired output bit patterns for each step, means toggle, are stored sequentially as words in memory. So this is something important when we'll be implementing the sequencer. So you should be remembering this, that they are stored as words in memory as usual. Each bit in the word corresponds to a specific terminal of the output module. Every time the sequencer instruction steps, it connects the next output pattern in the memory to this designated output module. The address of the first pattern word in the sequence is given in the sequencer instruction as the sequencer file address. So this is something really important, and I'll be asking this from you guys. The address of the first pattern word in the sequence is given in the sequencer instruction as the sequencer file address. The sequencer steps when the rung makes a false to true instruction. So basically the sequencer is working on toggle information. The toggle instruction or input will make the sequencer realize that I have to jump to the next instruction in the memory. So how do a sequencer jump from one instruction to a second instruction? When the rung makes a false to true transition, that is a toggle. Other version of sequencer instruction allow the programmer to insert a time value for each step. So you can also choose a time value for the steps, while the normal sequencer SQO that we are going to use, they make a transition when the input instruction makes a false to true transition. Here is the symbol for the sequencer. So here are some informations that you need to know about the sequencer file address. This is the first address of the sequencer file, which stores the sets of outputs. Then we have destination address, the output address or slot to which the sequence file words are transferred with each step. You'll get to know about this in very detail when I'll explain you the example I'm planning to do. So the length of the sequence file, that is the number of steps in the sequence. Enable, it goes true when the sequencer rung is true, and done pin, it stands for done, goes true when it has operated on last word in the sequence file. Then is the control address. It's the address that stores the control bits, enable, done and words length of the sequencer. So let's move to the example that I have for you guys. So the first thing that you are going to do is that you are going to pick the sequencer, and here we are going to use SQO. I'll just drop it off here. You can see that it is a sequencer output. It has different pins, different addresses, file, mask, destination, control word, length and position. Okay, so let's start with file. What is file? The file is the main memory thing, the main register of the sequencer, from where the sequencer is going to extract the information, extract the data that it has to transmit to the outputs. So I'll choose N7:0. So what does this N7:0 represent? N7:0 represents the integer register. As I had told you earlier, that this stores the word instructions, and we are going to store the words in integer register of the sequencer, and the integer register is represented by N7. The binary register is represented by B3, and I'll be asking these questions from you guys, so take good care of these things, that the integer register is the N7 one and the binary register is the B3 one. And I'm starting from column 0, that is the very first line of the integer register. Then is the mask input. What does this mean? This means that what outputs are you going to turn on? I'm writing out N7:10 over here. Why I am doing this would be clear to you in a few seconds. So I've written N7 and the 10th line I have referenced to it as the mask. Now the next thing is the destination. So you have to give the destination address over here. I'll be giving this O2 0. So we are starting with the O2.0, which is the second output. As you know that in RS Logix Pro over here, what we are referencing to is the output over here, and the output is starting from the port number 2. So I have written it out over here. Then is the control word, and that's something that you are going to write as it is, R6:0, because this is the control word in the registers. Then is the length. You can keep your length from 0 to 100, any value. What I'll be choosing is 5. Okay, I've already chosen 5, so I'll be choosing 5. Then is the position. You have nothing to do with that. You can just make it some 1 or 0. It is right now at the position 4. When we'll toggle it, it will move back to position 5 and then again position 0. So now let's choose an input switch for it. And here's my required switch. I've just plugged it in. I'll be referencing to the first switch so that I can toggle it off and on through this. Now what I have to do is that I have to select or make some values that I need to be transferred to the output switches. So I'll just right click over here and I'll go to the data table. This is something really important, so I'll be slow over here. Now in this table you have to choose the N7 integer register. As I told you, B3 is the binary register and N7 is the integer register which we are going to use for storing the words. I've clicked on N7 and here you can see that N7 is starting from 0 and it goes to N799. Okay, so this line over here, which is going from 0 to 15, represents each of the output bulb over here, which goes from 0 to 15. Okay, so what this means is that each and every 0 and 1 over here will represent a bulb that I have to turn off or on, or any output that I have to turn off or on. So here we will start off from N7:1, because you have to remember that the very first instruction, the register N70 will not be transferring to the destination, to the output. So the very first N7:0 is, you can say, a don't care instruction. it would not be transferred to the output destination. So we'll be starting from N7 colon 1. Now what I've done over here is that I've turned on the bulb number 1, and I'll turn on by double clicking the bulb number 9, the bulb number 10, and the bulb number 13. Okay, and then in the next instruction N7-2, I want the bulb number 0 to be off, the bulb number 1 to be on, the bulb number 2 to be on, the bulb number 3 to be off, the bulb number 6 to be on, the bulb number 9 to be on, the bulb number 10 to be off. I can change these states from any 0 to 1, or you can turn them back to 0. So that's something memory that I'm making for myself for the outputs, and these inputs would be transferred to the outputs, or in other words you can say that this is the sequence that is being stored in the memory for the output bulbs. Now here we will go from N7-1 to N7-5. Why? Because the length of my program of my sequencer is 5. So there would be no use of changing the values of N6 table, N7 colon 6 table, because the sequence length is from 0 to 5. The 0th instruction is something that is not going to be transferred. So N7 colon 1 to N7 colon 5 is the set of instructions that would be transferred to the output register as a sequence. Okay, so that's what we are dealing with in the file, and here's what the length means, and this is what the output destination means. Now one thing that remains is the mask input. So the mask is N7 colon 10. What does the mask mean? I'll just show you something, that in N710 I have turned off the first 7 bulbs, I guess 8 bulbs, and the rest of the 7 bulbs are turned on. So bulb number 8 to 15 are turned on, while bulb number 0 to 7 are turned off. So what does this mean? We'll implement the circuit first, and then we'll see that what happens. That would give a better picture, a better idea of what is happening over here to you guys. So let's start. I'll just place it over here. I'll go to download to PLC, and then I'll go online. I'll just click on run. Okay, so here what we have is input switch 1 would be turning on or off these lights according to the data table that we have in the N7 register. So I'll just turn this on for the first time, and you can see that the output number 9 and 13 have turned on. But was it really our instruction? So I've gone to the data cable. I'll move to the N7 integer, and you can see that the N7-1 says turn on the light number 9, 10, 13, also with the light number 0. But the light number 0 over here is off. So what did happen over here? The rest, you can see that the mask inputs over here are on from 8 to 15, while the 0 to 7 outputs are off from the mask table. Okay, we'll move forward further so that we can check what is happening over here. I'll press it out off and one toggle again. So what is happening over here is that, okay, sorry, there was some issue last time. We were at the position 4, so it was implementing the position number 5. Now we are at position number 1. So what's happening is that 9, 10 and 13 should be on along with the 0, 1. So 9, 10 and 13 are on, but the 0, 1 is off. You can see. So let's toggle it again and see what's happening. I'll turn it off, turn it back on. It has gone to the position 2, which means N7:2, and it says the light number 1, 2, 6 and 9 should be on. But you can see that the light number 9 is only on. The light number 1, 2 and 6 are off. Why is it so? This is because we have turned the lights number N7 to 10 off. You can turn them to binary and decimal from here. This is what is being controlled from the mask inputs. So the N710 input, that was the mask input, is controlling that what lights would be controlled by the sequencer and what lights would not be controlled by the sequencer. So I had turned the lights number 0 to 7 off for the sequencer and light numbers 8 to 15 controllable for the sequencer. That's why during the position number 2, when the lights number 1, 2 and 6 should be on, 1, 2 and 6 are off because they are not accessible by the sequencer. Only the lights number 8 to 15 are accessible because I have turned them on in the mask input. Secondly, the lights which are accessible, they have only light number 9 being turned on. So that's why light number 9 is being turned on over here while the rest of the instructions are not being implemented. I'll turn it off again and turn it back on, and you can see the position is on position number 3. That means N7:3. Here it says light number 14, 12 should be on and the rest are off, and here you can see that the light number 12 and 14 are on and the rest are off. Now we'll move to light number position number 4, and the position number 4 says every light should be off, and you can see that the position number 4 instruction is true, but each and every light is off. Now moving to the last instruction that we had, so it's the position number 5, which says light number 13, 9 and 6 with 0 are on, but here we have only the lights number 9 and 13 on. So we'll have gone to the data table. Okay, and what we'll do is that now we'll turn it back to binary, we'll go offline, and this time we'll turn all the lights from 0 to 15 on for the sequencer. So here we have N7, 10, and I'll make it 1, 1. One other way to make it 1 is to convert this to hexamer, and here I'll change the values to F, 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 F. Okay, so now when you'll go back in binary, you can see that the N710 has been converted to all ones. So that's an easy way to convert this binary language to a hexamer and then making all of them on. So I'll just go online now, download it to PLC. Now I'll go online, and now you can see that the position is at 0. I'll turn it off and turn it back on. Sorry, I have to run it. Okay, so the position is at 5. We'll move to position 1 and we'll see the data table. Now you can see that in the N7 integer data table, the position number 1 says that the light number 0, 9, 10 and 13 should be on, and now you can see that the light number 0 is really on. So why is it so? Because we have turned it on, or you can say that we have made it accessible for the sequencer. Yes, light number 1, 2 and 6 are now glowing because these outputs are now accessible for the sequencer. So this is the way you are going to control the outputs from the file register to the destination, and the mask input will control that which of the lights are going to be accessible by the sequencer and which are not. So the tasks include: system has a push button LS1. When the user presses the LS1, first time the fan goes on, second time the bulb goes on and fan goes off, the third time the bulb goes off. So if you have to implement using sequencer, I guess that's pretty much easy after I have implemented such an example for you guys. Then you have to write a program that will turn on flashing lights one after another for 1 second. So this would be using the sequencer for time input, and then you have to using ladder logic, use only one stop start station consisting of only one NC contact and one NO contact, 2 motor starters and 3 control relays, creating the following cycle. No timers or counters. So when the start button is pressed, motor 1 will start and run until stop by pressing the stop button. When the start button is pressed again, motor 2 will run until stop by pressing the stop button. When the start button is pressed again, motors 1 and 2 will run until stop by pressing the stop button. Pressing the start button again will now start the cycle over. And the last task is for you guys to write a program for the two-way traffic signal. So I guess that's pretty much easy. So you have to remember that you can use timers over here that will turn on a flashing light one after another for 1 second, but you cannot use timers or counters over here. And I guess these are pretty much simple and easy for you guys, but still, if you have any kind of confusion or question, you can mention it in the session or in the comment section. So take good care of yourselves, submit the reports in time. Take care. Allah Hafiz.